this video, we're going to talk about Albert A. Michelson. And so in the previous videos, we talked about relative velocity and inertial reference frames. So given that the speed of light is 2.998 times 10 to the 8th, the physicists, back in Michelson's time, were asking the question, what is that velocity relative to? So that's what he was trying to figure out. This comes from the Encyclopedia Britannica, and here we have Albert Michelson, and he was born in Germany. He came to the United States when he was 2 years old. At age 17, he entered the United States Naval Academy. He did well in science, but was rather below average in seamanship. And in 1878, he began work on what was to be the passion of his life, which is the accurate measurement of the speed of light. And he did succeed in making very accurate measurements of the speed of light. So he devised for this an interferometer, which you will be familiar with after you do the Michelson interferometer lab. And so his intention was to use this to measure the speed of light on Earth and then use that to figure out Earth's velocity relative to the ether. So I'm going to go back to Introduction to Electrodynamics. And so the idea was that suppose you have the ether wind traveling this way. Then if the light is moving this way relative to the ether wind, you would measure a smaller value because you'd add the speed of light to the speed of the ether wind and get a shorter measurement for the speed of light. If the light's traveling with the ether wind, you'd get a larger value because it's going in the same direction. And if it's perpendicular, there would be no change. But what Michelson and Morley found was that the speed of light was the same in all directions. So no matter how they did the measurements, they always got the same value for the speed of light, which was surprising. So that would lead us to believe that if we are measuring the speed of light on Earth and always getting the speed of light, then there's something special about Earth because the ether's not moving relative to the Earth. But that doesn't really make sense because we know that the Earth is revolving around the sun. So why would there be something special about the speed of light on Earth? So let me just go back to Michelson for a minute here. Okay, so in 1907, he won the Nobel Prize in Physics for his optical precision instruments and the spectroscopic and meteorological investigations carried out with their aid. And he also used his interferometer to measure the diameter of stars. He's famous for the Michelson-Morley experiment, which we just talked about. And that proved that, the speed of light was his final measurements say that the speed of light is 2.99774 times 10 to the 8th, and today the accepted value for the speed of light is 2.99792. There is a PowerPoint on the M drive called Gallery of Physicists, and Michelson is the first one in that PowerPoint, so you can look there, and it has the information that I just gave you. Okay, so I'm going to share a link with you where you can read more about the Michelson-Morley experiment, but it is, and I think they say it somewhere here, if the Earth were traveling through the light-conducting ether, then the speed of the light traveling in the same direction would be expected to be equal to the velocity of light plus the velocity of the Earth, whereas the speed of light traveling at right angles to the Earth's path would be expected to travel only at the velocity of light. Then that's what we are showing here. So if the ether wind is blowing this way relative to the Earth and the light is also traveling in this direction, then you would measure something faster for the speed of light because it's being blown along in the ether wind. However, if the light is shining this way, the ether wind would be opposing it and you would get a smaller value. So that's what we are doing here. His earliest experiment signified that there was no difference in the speed of light and therefore no motion of the Earth relative to the ether. And so later on, they did the experiment again. The results were still negative, which means no motion of the Earth relative to the ether. This is perhaps the most significant negative experiment in the history of science. In terms of classical Newtonian physics, the results were paradoxical. Evidently, the speed of light plus any other added velocity is still equal only to the speed of light. To explain the result of the Michelson-Morley experiment, physics had to be recast on a new and more refined foundation, something that resulted eventually in Albert Einstein's formulation of the theory of relativity in 1905. Okay, so that's where that brings us to the speed of light is the same no matter what inertial reference frame you are measuring it in, and we will talk more about that in the upcoming videos.